Switching characteristics of a power transistor.
Forward bias.
PN junction with two parallel capacitances. One is deflection layer capacitance and a diffusion capacitance. Whereas the reverse bias PN junction has only deflection layer capacitance. Under steady state condition, these capacitance do not play any role. But under the transient conditions, influence the turn on, turn off behavior of the transistor. You can see the transient model of a BJT or the model of transistor under transient conditions, where CBE and CCB are the effective capacitances of a BE junction and CB junction, and whereas GM is the transient conductance of a BJT, is defined as the ratio of change in the collector current to the change in the base emitter voltage. These capacitances dependent on junction voltage and physical construction of the transistor. CCB affects the input capacitance significantly. RCE and RBE are the resistances of collector to emitter and base to emitter respectively. Base voltage is applied here. IB also rises, but IC is not going to respond immediately. There will be some delay time due to the capacitance CBE need to charge up to the voltage, that is VE, which is near about 0.7 volts for silicon and 0.3 volts for germanium. That delay is represented with the delay time TD. Delay time. After this delay time, the collector current is going to rise the full ICS, saturation collector current. This time is known as rise time. Rise time here depends on the time constant of the capacitance CBE. Delay time is to CBE need to get up to VBE, that is 0.7 volts, need to be charged. After that, it rises. TR is going to depend upon the time constant of CBE. Base current is normally more than that required to saturate the transistor. IB is more than ICS. This results the excess minority carrier charges is stored in the base region. The high overdrive factor, that is ODF, the greater is the amount of extra charge stored in the base. This charge, we call it as saturation charge, and it is proportional to excess base drive and corresponding current IE. IE equals to IB minus ICS by beta, which equals to IBS base saturation current ODF minus 1. Saturation charge QS equals to tau S IE, that equals to tau S IBS of ODF minus 1. The tau S is known as storage time constant of the transistor. When the input voltage VB is reversed from VB1 to minus VB2, the base current is also going to reverse to minus IB2. The collector current does not change for a time Ts. It is known as a storage time. Ts required to remove the saturation charge from the base. Since VB is still positive with approximately 0.7 volts, the base current reverses its direction due to the charge and the polarity of VB from V1 to minus V2. This reverse current minus IB2 helps to discharge the base and removes the extra charge from the base. Without minus IB2, the saturation charge has to be removed entirely by recombination and the storage time would be larger. Once the extra charge is removed, the BE junction capacitance, that is CBE, charges to the input voltage minus V2 and the base current falls to 0. The fall time depends on the time constant, which is determined by the capacitance of reverse bias BE junction. TF is fall time. Turn on time T on equals to TD and TR. Delay time TD plus rise time TR. This delay time is time taken by the capacitor CBE to charge from 0 to 0.7 of VBE volts, and TR is the time taken to rise from 10% of ICS to 90% of ICS. Turn off time is equals to TS plus the fall time TF.